Happy Monday. I hope you guys enjoyed your long weekend. We're going to start with our do now where we're reviewing our simplifying. Remember our rules of simplifying. No exponents with number bases, no parentheses, no negative or zero exponents, no same bases, and no power to a power. So let's put it into practice here. We've got 3a to the fourth b times 5a squared b to the third, just a multiplying with same bases problem. So we'll multiply our coefficients. 15 a to the fourth times a squared is going to be a to the sixth. B to the first times b to the third is b to the fourth, right? When multiplying, we're keeping the base, adding the exponent, and we are fully simplified there. Number 2, negative 9c to the negative second power. So we have to deal with that negative exponent of 2. I want to ask myself, what is the base of that negative exponent of 2? Well, it's just the c. The negative 9 is a coefficient. So only the c to the negative second power is going to move into our denominator, making this, making it negative 9 over c squared. And when that negative exponent moves down, it becomes positive. Now, number 3, we have a power to a power and a negative exponent. First step, take that whole power, right? That negative 4 exponent, we're going to put it in the denominator. Keep the parentheses. Now it's to the positive fourth power. So now we're going to do our power to a power rule. Remember, we multiply our exponents in power to a power. So it's going to be 1 over. When we have that negative 2, a negative coefficient inside our parentheses, we keep it in parentheses when we pull it out. Okay? A to the third, 3 times 4 is 12. B to the first, 1 times 4 is 4, so b to the fourth. C to the fifth, 5 times 4 is 20, c to the 20th. Now we just have to simplify that negative 2 to the fourth power. So I might come over here to the side so I can show my work. The parentheses show me that that's negative 2 times negative 2 times negative 2, right? Negative 2 times itself 4 times. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. Times negative 2 is positive 16. So our final answer should be 1 over 16, a to the 12th, b to the 4th, c to the 20th. And there we go. Today we're going to simplify some longer, more complex exponential expressions where we're going to see some division with our negative exponents. Based on the expressions we see today, really we're going to look to work with our negative exponents and our power to a powers first. So as we look at number 1, 6m to the negative fourth x to the fifth times 2m x to the 0. Well, one thing I like to do here with this multiplication, we can either combine the multiplication or move our negative exponent first. I'm going to say let's move that negative exponent down. So I think what's the base of the negative 4? Just the m. So just that is going to move down. When we do that, we get 6x to the fifth times 2mx to the 0 over 15m to the third. And now we've got that m to the fourth that becomes positive x to the sixth. You'll notice here we have a bunch of same bases to deal with and that x to the 0 power. That x to the 0 power is going to be 1, right? And 1 times anything is just itself. So in our numerator, 6 times 2 is 12. So that gives us 12mx to the fifth. If you wrote down 12x to the fifth m, that's fine. Commutative property of multiplication, right? Notice I didn't write the times 1 because it's multiplicative identity. It's just itself. In our denominator, 15, m to the third times m to the fourth is m to the seventh, and then we have x to the sixth. Now that our numerator and denominator is simplified, this is when I like to go ahead and start doing the division, so reducing and simplifying. So 12 and 15, common factor is 3. 3 goes into 12 4 times. 3 goes into 15 5 times. So I know in my answer I'm going to have a 4 over 5, and I look to my m's. M to the first over m to the seventh. That means we can cancel one m on the top with one m on the bottom, leaving 6 m's on the bottom, so m to the 6th. X to the 5th over x to the 6th, we can cancel 5 x's on the top with 5 x's on the bottom, leaving 1 on the bottom. Okay, and if you just want to rewrite so it looks a little nicer, 4 over 5 m to the 6th x is our final answer. As you get more comfortable, the steps sort of decrease, so you might notice going from moving your negative exponent down, you might realize and just go right ahead and combine those same bases in one step. It's up to you. For our notes today, I'm obviously going to show all of those steps out. Okay, so let's look to number 2, negative 9m and m to the negative 2nd, n to the negative 2nd, m to the 4th, n to the 0 power. One of the first things I notice is that m to the 4th, n to the 0 power, that's just going to be 1. So I might just cross that out, write myself a 1 there. Okay. Now I want to get ready to go and move our negative exponents. So the m to the negative 2nd has to move down, the n to the negative 2nd will move down, and the n to the negative 3rd will move up. Okay. So I'm just going to rewrite. Negative 9, now that'll be n to the 3rd up top. Right, we can write in our times 1 if we want to show that. And then on the bottom, 3m to the 3rd. Now we bring down our m to the 2nd and our n to the 2nd. Good. So we'll simplify our numerator, right? Just times 1 is going to be negative 9n to the 3rd over, simplify our denominator, 3m to the 5th n squared. And now we'll go ahead, reduce and simplify. 3 goes into 3 once, 3 goes into negative 9, negative 3 times. N to the 3rd over n squared. That's going to means we can cancel 2 n's on the top with 2 n's on the bottom, leaving 1 n left over in the numerator. So negative 3n over m to the 5th. And there we go. As you go through and you work on page 14 for your classwork, make sure you're showing your work and you're checking that your answers are fully simplified. Make sure you're remembering to reduce the coefficients as if they were just regular fractions. I find that sometimes students forget that because they're so concerned with the exponents. So this is due on Google Classroom today. On Google Classroom, you also have available to you the exponents review sheet that is due on Wednesday, and we have our exponents quiz on Thursday. Today's math jokes for Matthew folks is another visual one. Here it is. What is this representing? Noah's Ark. Noah's Ark, circle, ark, N-O-H-A, Noah's Ark. Have a great day, guys.